All right, let's dive right into this. Welcome, everyone, to the Explainer. Today, we are exploring a massive, and I mean absolutely massive, paradigm shift that's happening right now in how we build software and manage artificial intelligence. We are moving completely away from the era of just talking to AI chatbots and stepping into a future where we design reliable, self-correcting autonomous systems. It is a completely different ballgame. So, cast your mind back to early 2023. Do you remember the absolute crazy hype around prompt engineering? I mean, jobs were popping up everywhere offering like 335 grand a year just to know how to talk to an AI. As Andre Karpathy famously noted back then, English really felt like the ultimate programming language. But honestly, that era is already dead. Why? Because as our sources point out, you can have a perfectly worded prompt, but if you combine it with the wrong context, you are still going to get garbage out. And that brings us to the core contrast we're exploring today. In 2023, the focus was all on prompt engineering. You were essentially babysitting a chatbot. It was kind of like managing an intern who has zero short-term memory, feeding it one instruction at a time, crossing your fingers for a good output, and then manually correcting it every single time it messed up. But today, in 2026, the reality is loop engineering. We aren't crafting individual instructions anymore. We're building repeatable workflows. These are systems where the AI can gather its own evidence, take action, and crucially, self-correct without us holding its hand for every single click. So here is our roadmap for the explainer today. First, the death of prompt engineering. Second, entering the loop era. Third, the anatomy of a coding loop. Fourth, taking an aviation approach to AI. And finally, how to avoid some really nasty AI failure modes. Chapter 1. The death of prompt engineering. Let's trace the history a bit to see exactly how we arrived at this whole new paradigm. Looking at the timeline of AI skills progression from our sources at Inimize, you can see 5 really distinct stages here. We kicked things off in 2023 with simple autocomplete. The AI basically just saved you some typing. Then came prompt engineering, where we obsessively tried to find the perfect phrasing. By 2025, we woke up and realized, wait, phrasing doesn't matter nearly as much as the actual information, which led us straight into context engineering. Then, early 2026 brought harness engineering to scaffold a single agent's run. And finally, boom, we arrive at loop engineering today. And there's a really clear pattern here, right? With every single one of these stages, the human engineer is being moved further and further away from the keyboard and much closer to the actual thinking and system design. If you want absolute proof of how profound this shift is, look no further than this quote from Boris Cherny. He leads Claude Ghetto over at Anthropic, and he explicitly states his job is no longer prompting. His job is writing the loops that prompt the AI. Think about that for a second. The underlying unit of software engineering isn't the prompt anymore, or even the context. The fundamental unit is the cycle itself. And here is exactly why adapting to this shift is absolutely critical for your business. Data from McKinsey shows that while a massive 88% of companies used AI in 2025, only 6% actually captured real value from it. 6%. That's practically nobody. The vast majority of these companies bought the shiny new AI agents, but they completely failed to redesign their workflows around them. Which brings us perfectly to Chapter 2, Enter the Loop Era. Let's define what this new paradigm actually is and look at the academic theory that backs it all up. Now, what's really fascinating about the structured cognitive loop is how it solves a massive problem with AI. According to a research paper on the topic from Archive, the early frameworks we used stuffed everything, reasoning, memory, execution, all into one single prompt. Unsurprisingly, this caused AI to forget things, completely hallucinate, and just drift off task. It's actually a lot like human cognitive limits. Imagine trying to do complex math in your head while someone is yelling random numbers at you. Your working memory just overloads. The solution here is architectural separation. The language model is used strictly for cognition. The memory is maintained completely externally, and the execution? That's guided by a separate goal-directed loop. In practice, this means you are totally transitioning away from manual prompting and instead defining an explicit cycle. The AI is set up to act, observe reality, reason about what it just saw, repair its own mistakes, and, crucially, know when to stop. You aren't just giving it the answer anymore. You're defining the goals, giving it sensors so it can observe the environment, and setting up approval gates. This way, the agent can move work forward and know immediately when it goes off track. Okay, Chapter 3, Anatomy of a Coding Loop. Let's dive into the deep mechanics of how you actually go about building these self-correcting flows. When you're building a self-correcting workflow, it generally follows this continuous agent-driven cycle. The agent plans a step, executes it, verifies the result, and repairs it if needed. The massive, game-changing shift here is step 3, verify. In the old prompt era, getting an error message meant you failed. In the loop era, a test failure or an error message isn't a dead end at all. It's simply new context. It's fuel that feeds right back into the repair stage, driving the next step of the loop totally automatically. To make that cycle actually work, you need these 5 essential building blocks outlined by .ping design. You've got goals, so the AI knows what done actually means. You need skills, so it can take reliable actions, repair logic, so it knows exactly how to respond when things inevitably break, and termination logic, so it doesn't just run in circles and rack up a massive cloud bill. But if you take nothing else away, pay special attention to sensors. Sensors are how the loop actually sees reality. We're talking logs, test suites, or screenshots. Because without sensors, your AI agent isn't reasoning. It's essentially blindfolded and just guessing with extreme confidence. Chapter 4, the aviation approach to AI. So, now that we have these highly capable, autonomous loops running, how in the world do we humans actually govern and manage them? Well, this requires a total mindset shift. Think of the tools that configure what the AI sees as the cockpit instruments. But the loop itself? That is the Autopilot program. And this brilliantly illustrates our new reality. Just like a pilot in a modern airliner, your job is no longer to manually steer the plane by pulling every single lever. Your job is to supervise the autopilot, thoroughly understand the instruments, and know exactly when you need to step in and intervene. To supervise effectively, we absolutely have to understand the difference between these 2 critical concepts highlighted by Strata Identity. Human in the loop means the AI physically pauses. It stops what it's doing and waits for a human to approve an action before it executes. This is non-negotiable for high-risk actions like moving real money or changing sensitive security permissions. On the flip side, human on the loop means the AI acts totally autonomously, while a human is just monitoring the outputs as they happen. And that's totally fine for low-risk, easily reversible stuff, like having an AI draft up a quick internal email. But here is the major catch. Having a human in the loop is completely useless if that human just blindly clicks approve every single time the AI asks, treating it like an annoying terms and conditions pop-up. The aviation industry learned this the hard way decades ago. Following a series of tragic crashes, they didn't just tell their pilots to, pay more attention. That doesn't work. They instituted crew resource management, simulator-based practice, and structured briefings to eliminate human factor accidents. Tech teams need this exact same rigorous practice discipline today. You need hard guardrails against automation bias, and you absolutely have to practice overriding AI agents in a safe sandbox before you ever try doing it in a live production environment under stress. And that brings us to Chapter 5, Avoiding AI Failure Modes. Because what exactly happens when these autonomous loops are built poorly? Well, if you don't build your loop correctly, you are going to start seeing these issues immediately. We get thrashing, where the AI just endlessly edits code, literally running in circles. There's overfitting to tests, where the AI technically makes the test pass, sure, but completely ignores what the human actually wanted. You've got context drift, where the agent is chugging along based on totally stale data. Unsafe autonomy, where an agent, say, deletes an entire database just because you forgot to give it a human-in-the-loop checkpoint. And finally, automation complacency, where your team gets lazy and just blindly trust whatever output the loop hands them. Believe me, bad sensor design and unpracticed teamwork will absolutely guarantee these catastrophes. So the absolutely crucial point here is this. Building loops safely isn't just some nice technical best practice anymore. It is quite literally becoming the law. As noted by Strata Identity, regulations like Article 14 of the EU AI Act now require demonstrable, trained human oversight. Regulators and auditors aren't going to just look at a nice flowchart and take your word for it. They demand enforceable identity governance, detailed logs, and hard proof that humans are genuinely making the final judgment calls. Which leaves us with this final, provocative thought for you to chew on regarding your own daily workflow. Are you actively designing the loops that dictate your work? Or are you just blindly pressing go on an AI tool? The era of prompt engineering is completely over. The single most important skill in software today is designing resilient, self-correcting systems that do the heavy lifting for you, while keeping humans firmly seated in the judgment chair. Thank you so much for joining me for this explainer, and I highly encourage you to go take a hard look at your own workflows today.